Hi, I'm George Giorgio. I'm a STEM ambassador. I live in West London and I am going to talk to you a little bit about how I got here and my sort of interests and all sorts of fun stuff that I get up to, hopefully. Right, so I did my O-levels, which are GCSEs now. Went on, did my A-levels, and then did an engineering degree. The obvious route would then be to get an engineering job, but no, I went into the city and became stockbroker and fund manager. Doing a mathematical degree opens doors to all sorts of other avenues. So yes, I was a stockbroker and fund manager for quite a few years, and then I decided to go out on my own and do some production, film production, and also specialist finance around that industry and other sort of specialist industries. But I also have a passion for classic cars, so there's a bit of finance on that side as well. And I have a couple that I've restored and generally play about with. Yeah, and also quite techie stuff, things like cameras and hi-fi and 3D printers. Which I'll show you in a little while. But yeah, what I would say is it's worth going into further education, and certainly anything sort of technical and mathematical will open doors for you for other avenues that are not necessarily directly what you study. So if you haven't really got a clue of where you want to go once you've finished your studies, then it gives you options. So now turning to 3D printing, I first got into it around the sort of early 2010s, about 2011, 2012. Built my first 3D printer, which didn't really work that well, but it allowed me to print some pieces that allowed me to build a better printer from going by the sort of rep-rap sort of ethos, replicators, machines that replicate themselves. Well, that was the idea at the time, before 3D printers became commercially available. So I built a rep-rap printer. Most of them are controlled using an Arduino board with stepper motors and a hot end and nozzle that melts plastic. I mean, the way they work is that they inject plastic onto a bed, build a layer, then shift up a touch, build another layer, and you build a 3D model in layers. There's all sorts of things that you have to overcome. But it's quite satisfying. They're quite good to watch, actually, doing their thing. So yes, I built a rep-rap and then built another kit, a commercially available kit from there, which is my main machine at the moment. I also have another commercially available machine, which is a sort of secondary machine, which I use for sort of fast and dirty sort of proof of theory print, because it's it's quite a simple machine. And it works quite quickly. But this, I'll show you the main one in a second. The main one is it has got quite a big bed, and the actual prints are pretty impressive, considering it didn't cost that much. Right, I'll show you around it. Okay, so this is my current machine. Again, it's an additive printer, so it feeds from a spool of, in this case, it's PLA plastic, 1.75 millimeters in diameter. That goes into a heater and out of a nozzle, and it gets printed onto a glass plate which is heated. Now you've got 3 axes, so that's the Z, and there are two Z motors, so those are stepper motors there. There's a stepper motor in there that pushes the filament through the heater. That is the X-axis stepper motor, and that is the Y-axis stepper motor. So the machine, that's Y, that's X, and I'll show you Z in a second. So the theory is that it feeds plastic, melts it, and builds 3D models. You actually feed your model, which you've either built or downloaded as an STL file into USB port there, and then you run it all off this control panel. Now I'll show you how it zeroes itself. Where are we? So I'll just home it. Oh, that's quite noisy. Probably needs a bit of oiling. And there are end stop switches which do that, which tell it it's got to the end of its travel. So there's one, where are we? There's one there for the Y-axis. And you can get down here, so the tolerance is pretty much width of a sheet of paper, because it has to inject the plastic onto the heated bed and make it stick. So it squashes it down onto the glass and builds a model from there. If it doesn't stick, then you end up with a nasty sticky mess. But yeah, it's quite a good bit of kit actually. It's quite reliable, and I haven't had too many problems with it so far. Touch wood. So how useful is a 3D printer? Well, you can print models. Now you can download quite a lot of things from places like Thingiverse. For example, this fish, and you can see how it's layered up there. But the thing about this was it articulates, and that was a single print. Basically, it's printed all the hinges in one go. I didn't have to put any of that together. That just printed out like that. I took the bits of support that, and that's the other thing, you do need to use supports for some models, all depending on which way you print them. Now, if you're printing something like this, it's quite a simple print, but it will have supports in some of these joints, which you then have to scrape out. But that's come out quite well. Something like Yoda, again, you can see the layers in the base, and you would have supports for the arms, for the ears, because there's quite a big overhang there. Okay, so you've got an Apollo and a Soyuz from the mid-70s. That was on the NASA website, as was Mars rover, which is, now this is all modular and all sort of articulates, so you can turn wheels. That's Yoda. So it can turn. The arms move. But again, that was on the NASA website. So a great little model of the Mars rover. Now, models are all well and good, but on a more practical level, you can print things out that are quite useful. I mentioned hi-fi earlier on, and my turntable has a fairly non-standard head shell. Now, this is the original one that came with it. They're fairly scarce and quite expensive if you find them. So I went on to a 3D CAD program and made my own. 3D printed it, and there is a moving coil cartridge instead of a moving magnet one on the turntable, and I can swap those over. They're exact fits. So that's additive printing using PLA mostly. So the PLA is a plant-based plastic, so it's fairly environmentally friendly. You can use ABS or even nylon. They tend to make a lot more smell, and they're not quite as safe as using PLA, but they have different properties. But I am also going to get a liquid-based system next. It uses a resin, a photosensitive resin, that where this system uses a nozzle and injects down onto a bed and builds a 3D model upwards. The resin-based system has a vat of resin, has an LCD, a UV LCD that makes the resin react and harden. And there's a plate that sits in the resin just above the bed to give you the height of resin, and it basically takes a picture for every layer. So it's still layering, but it's layering in the reverse way to the nozzle-based system does. It's more accurate. The actual layers are much finer, so you wouldn't necessarily see any of the lines that you saw on the models I just showed you using that system. The downside is that where my main printer has a bed that's 220 by 220 millimeters, the resin is basically the size of the LCD, and that is, I think, by, on memory, 150 by 90, so about a quarter of the surface area of the big printer. But for very fine detail, it's probably worth looking at, and they've come down a lot in price, so I'm looking forward to using that. So enough about 3D printing for now. It's quite useful. It's useful to have around, and yeah, it's an interesting thing to be. It makes you do computer-aided design and rendering, and then converting into a file, an STL file, which is basically a sliced file, which the machine can understand. But yeah, that's enough about 3D printing. Let's move on to drones. I have built my own. Again, something that I got into probably 7 or 8 years ago. Really started on a practical. I wanted to sort of see the state of my roof, so I actually bought a small drone to have a look, which was fun, but there was more to it, and I then looked at the actual engineering involved, and they're relatively straightforward to put together. I mean, basically, much like a 3D printer, they are, or they can be, off-the-shelf parts. You need a frame for everything to bolt onto. You need some motors, some props, a battery, and a brain for it to work. You can add cameras so that you can see where you're going and photograph things. But the fundamentals are, it's a 4-bladed, effectively a helicopter. Instead of having a single rotor giving thrust and a tail rotor to stop the counter rotations, you've got 4 or 6 or 8 rotors, fixed rotors that change speed to keep attitude, but you've got them counter rotating each other to counter any centrifugal effect. So I haven't got one of my big drones here because I'm indoors, but I have got a small one that I can sort of demonstrate the basic principles, and yeah, we'll take it from here. Okay, just to demonstrate the principles, I've got my mini indoor quadcopter, so there's 4 blades. Now the top right, or at least the right hand blade here, is a clockwise rotating one. The left one is counterclockwise. Opposite that is a clockwise. And next to that is a counterclockwise. So they cancel each other out. They cancel each other's torque out, which means that the whole thing doesn't rotate on itself when it's flying. This one's got a camera, so you can use it as a first-person machine, so you can see where you're going, and take pictures, of course. It works by having 4 motors driving the props. There's a brain in the middle that controls the motors, so it's and there's a little battery inside. There's 6 gyroscopes. Now the smaller the drone, the more skittish it is, and they tend to be fairly lively at this sort of size. The bigger the drone, the more stable they are, and they can also carry payloads and carry sort of cameras, so they're a stable camera platform as well. But these little ones sort of skit around a bit, and you've got to be on your toes. So here it is, all primed and ready to go. It's got 6 gyros, which might sound like overkill, but believe me, it does need them. And you can control it with a phone, but I've got a mini controller here as well. There we are. So you can see all the So you can see it's quite skittish even with 6 gyros, but it's good fun, and it's ideal for messing about indoors. But I've built proper quads and hexes, which can be as sort of wide as a metre wide, with blades normally made of carbon fibre, to match, to actually lift the thing. Big, powerful things that you normally need a license for if you're gonna go that big. You should really have a license to be able to fly anything in public now, and the model flying clubs tend to facilitate that, which is quite useful. But yeah, it's always worth getting some training and some practice. Simulators are quite good, but there's nothing quite like flying the real thing. So yeah, I've and the big ones tend to be fairly modular, so you can buy off the shelf parts like engines and rotors. The actual brain that controls the thing, you get a gyro, GPSs, and cameras for both using a headset for first person, but also for actually filming stuff. So quite useful, and you can take it further and actually make a living out of it. Nowadays, it's a fast-moving market in drone photography, but also people at GCHQ might take you on to fly their drones. But that's another thing. Okay, so there we are. That's drones for now.